Welcome to this week's lesson, and today we're going to get into what we call the direct line method, and we'll also get into the polar line method. Now, these are two very different types of methods to be able to draw lines with, but they're both fairly easy, especially this one, the direct line method, which we're getting ready to start with right here. Now, this is one of your drawings that you're going to do for me this week, and I want to show you how to get started with this. I'll just minimize this and we'll pull that up. I'll minimize my AutoCAD too. That way we can put both of them in the same slide. Alright. Now, I want to come here to AutoCAD, and I'm just going to close my property out a little bit so you can see a little bit more of the screen. And go File, New, and I'm going to make an architectural template out of this one. And come in here and hit architectural, and decimal degrees is fine. That's all fine. And let's put 100 foot by 100 foot, giving me plenty of area. Alright, as soon as this opens up and we're ready to draw, the first thing I always do is hit Z for zoom and go to all, and it opens up my entire limits. So now, like I said, I hit Z for zoom, enter, and then you can either hit A for all, or you can click on all, and it opens all my limits so I can draw. Now this drawing looks like to me, I have to move it over. It's starting at 5 foot, 5 foot. So I hit line, and I want to start at 5 foot, 5 foot, and Y. Enter. Well, so I want to start my line. I want to start 5 foot, 5 foot. Enter. And you can see right there, I'm starting my line. Now, in the direct line method, it's really easy. Now, down here, we've already looked at the status bar, but we quickly know that this one right here is what we call object snap. And that's what allows us to snap to end points, mid points, center points, and things of that sort. Makes it really neat and really handy to be able to click those points. We also got this other tool over here we call ortho. Now, ortho means 90 degrees, and what that does is you can see you can either draw horizontally or vertically in the X and Y direction. Now, to do the direct line method, it's really easy. You just got to get it going in that direction, and in ortho, we'll just, because if you look down here, we're going across this thing 22 foot. All you'd have to do is get it going in the right direction, type in 22 foot, and hit enter. Now I want to go up 8 foot, hit enter. Go over 15 foot, hit enter. Go back down 5 foot, hit enter. And make sure you're putting your feet symbol on there as well when you do this. Now on this one here, I want to go over 18, and I have to hit my foot mark. You all see it down here, and hit enter. And going back up 5 foot, enter, and then coming over 20 foot, enter, and then up 45 foot, enter, over 30, enter, down 5 foot, enter, over 25, up 15 foot, enter, over 20 foot, enter, and it should close on itself, and it does. Just like that, you've quickly got that drawn in by using that direct line method. Now, you can also, in the direct line method, you can use angles. You have to take that off, but you can have it pointed in any angle, and all thing you have to do is just type in your distance, and it'll put it in there. We'll talk about that a little bit more with angles here in the next little bit. However, I want to take, and if I want to dimension this, come up here to annotate, change it right here to annotative, And whatever scale you're working with on the annotative scale, most of the times in residential architecture you use 1/4 of an inch equals 1 foot. And then after you get that set down here, see the little Mitsubishi looking sign and see it up here at the annotative? If you'll click right here on that little diagonal arrow, make sure you're on annotative and hit modify, and we're going to change the primary units on this for the dimension style to architectural. Text should be 1/8 of an inch. Okay on that. Close. And now I can go around this thing and dimension it, and everything should be right on the money when I go around this thing. And you can see right now it's 22 foot. Hit my space bar, it lets me repeat my command. Hit my space bar, it's a little quicker to do that, and you keep on rolling. And just make sure all your dimensions are accurate as you go around this thing. Now that right there is what we call the direct line method. I want you all to utilize that. Now the next thing that we're going to talk about is going to be the polar method. The polar coordinate method looks like this. You have a distance with an angle. Okay? So let's talk about that just a minute. First thing I want to do is I want to start drawing this one, and I'll show you how to do it. And we'll just draw just the first two just so it'll make more sense. So this one right here, this is a mechanical drawing, and this is one of them you're going to do today. So I'll hit File New up here, or hit the New button. And hit OK on that. This one's going to be a decimal form. And if you go back, decimal form precision, this thing goes over 4 places, so we have to have a 4-place precision, decimal degrees. Now, remember this? I told you earlier when we start setting this stuff up, this is where this comes into being the importance of this. If you'll notice, east is 0. This is kind of defaulted in AutoCAD. East is 0, north, west, south, and other. East is 0, and it goes, this one's going counterclockwise. Just remember where your zero's at. Hit next, and see how it's counterclockwise? Make sure you understand it, because zero's at east, and it's going back 360 degrees all the way back to itself. This one here, this will work for that. And when we get started drawing on this, I want to hit my line. I'll do my direct line method. I'll just start out at 0, 0. Real simple and real easy. And you can see my line starting there. I want to type in 1.2201. It's a real accurate number. I'll zoom in there to see my line. I want to come up 0.9276, enter. And now I'm ready for that angle. I want to turn this ortho off. And you don't have to turn ortho off to do it, but again, to do this polar coordinate method, you have to make this your 0 point. And to do that, you hit at, if you remember doing that relative movement. So at makes this my new 0, 0. So all you have to do is type in your distance, which is 3.1497, and then put this in there. That means angle in AutoCAD. Okay? And then type in your degrees, which was 28, and then hit D for degrees and hit enter. And you see how that shot that up there for you? Now I'll go ahead and I'll put the other one in. And the reason that I said that back here was so important, at 28 degrees, well, this right here for the east, you know, when we were designing our setup, this right here going east was 0, and going back counterclockwise, it went all the way around to 360. So this one from 0 up here to 28 degrees would be accurate. Now you got to watch out. Like this one right here, for instance, it's saying from this line here down to here is 21. Well, if this is 0 going due east and it's going around 360, we got to do a little calculation on that, because it wouldn't be 21, would it? It would be 360 minus 21. So if you had a calculator handy, you just have to do 360 minus your 21, which of course would be 339. So your angle would be 339. So hit your line. Well, it's already on line. And hit at, make this 0, 0, make it a relative movement. Type in 2.4307 and then do an angle sign. And then type in, what did we come up with calculator-wise? It was 339. So it's 339 D for degrees. Enter. Now let's just do a quick check on this. All this right here should have come in right. It's all right. Now I want to check the length of this, and to check the length of it, you'll have to change it from linear to aligned right here, just like that. 3.1497. Let's make sure that's the right number. It is. And I want to check now this one here, make sure we got our lengths right. Use that align button again. Perfect. Now I want to check the angle, and to do that I'm just going to put myself a line from that point. Use my ortho straight over, no certain length on it, and I'll do the same thing with this one up here. That way I go in here and check with an angular measurement. There's my 28. Yes, I'm correct. And then I want to come over here and catch this one to this one and just make sure I'm right. And there's 21. Dead money on that. So that's how that you go in and use polar coordinates if you know the exact length of an angled line, and if you know the degrees on it, you can use polar coordinates. And this is going to be helpful for this other drawing that we're going to do, a survey boundary. And it's very simple. It's not very difficult. But if you'll watch that next video, it will be a Project 3 video in CAD 100.